Ever tried breaking a Kit Kat and ended up with a mess? Well, we're mechanical engineers, so we do it with science. Oh man, you're doing it all wrong. Don't just snap it. Use 3-point bending. 3-point bending is a simple way to test how materials respond when loaded. You support the object at both ends and apply a force at the center. This creates a shear force directly at the point of application, and a bending moment that's highest at the center. That's where failure usually happens. The moment, M, can be calculated by the force applied, P, times the length of the specimen, L, divided by 4. The stress from bending is given by this relationship, where the stress, sigma, is calculated from the moment, M, times the distance from the neutral axis, Y, divided by the moment of inertia, I. In our case, Y is the height, h, divided by 2, and I is 1/12 times b times h cubed for the moment of inertia of the beam's cross-section. Shorter bars need more force to break. That's because the bending moment and deflection decrease when length decreases. Since bending stress is proportional to the bending moment, and the stress applied is also smaller, so a larger force is needed to compensate. The end result? Long Kit Kats are easier to break, and shorter Kit Kats are tougher to crack.
Now hold on a second. Why is that so much easier than doing 3-point bending?
Well, now I gotta teach you about stress risers. Stress risers. When there's a sudden change in shape, like a groove or notch, stress builds up at that exact spot. In this FEA example, the new height in the notch is the original height h minus the notch depth d. In our Kit Kat, the groove has a thinner cross-sectional area as well, meaning it has a sudden change in its shape. This also has a new height, h minus d. Now, since the stress sigma is equal to my divided by I, and I, the moment of inertia, is proportional to h cubed, a smaller height leads to a much larger stress at that same load. So what did we learn? Kit Kats might be candy, but they follow most of the same mechanics as steel beams. Engineers find stress concentrations, understand bending, use chocolate for science. So next time you're sharing a Kit Kat, break it like an engineer.
Okay, that's good. That's good.